Hello and welcome to Maths with Mr Amison. Today I'm going to be talking about how to find missing sides and angles using trigonometry. Make sure you understand the trigonometric ratios by watching Mr Chowdhury's video, which is linked here or in the video description below. To start off with, I'm going to give you two examples, see if you can follow along the working out, and then I'll explain it afterwards. Once the working out is shown, if you feel like you need more time, please pause the video. So in this example, first thing I did is I wrote out SOHCAHTOA. Once that was done, I started to label the sides of my right-angled triangle. It's worth pointing out that I did not label the hypotenuse being opposite the right angle. The reason I didn't label that is because it's not a side length that we were given, and it's not a side length that we were interested in calculating, so I ignored that side. This was our opposite because it was opposite the non-right angle in our triangle, so it was opposite our 30 degrees in this case, and that leaves this side as our adjacent side. So then I wrote out our trig ratio. So tan 30. It's worth pointing out that whenever you write sine, cos or tan, it should always be followed by an angle. And that angle should always be the angle that we are interested in. Either the angle that we are given, or in this case, the angle that we're trying to calculate. So, tan, because we have our opposite and adjacent side that we are interested in, and 30 because that's the angle we are interested in. So tan 30 is equal to our opposite divided by our adjacent. So if I substitute those in, I end up with tan 30 is equal to x over 4, which means x divided by 4. If I then multiply both sides of the equal sign by 4, I end up with 4 lots of tan 30 is equal to x. So x is equal to 4 lots of tan 30, if I write that the other way around. Now tan 30 you can type into your calculator. It's 0.577, and it's a big long number that keeps going on. If I multiply that by 4, that gives me the value of x to be 2.31 to 3 significant figures. So I'm going to go through the second example in the same way. Please pause the video at any point if you feel like you need more time to understand. Okay, so in this example, we have our angle here that we're interested in, our non-right angle. Opposite our right angle is our side of 4 centimeters, so that would be our hypotenuse. Opposite the angle that we're trying to calculate is this length here, but seeing as that's not got any label, we're not interested in that side, which leaves this side as our adjacent side, which means we are using our adjacent and our hypotenuse. So using SOHCAHTOA, we are using the cosine trigonometric ratio. So cos of our angle, cos x in this case, because x is the angle we're interested in, is equal to our adjacent side divided by our hypotenuse. I always like to write SOHCAHTOA where the middle letter is slightly above the rest, just to show that it's this letter over this letter. Adjacent over hypotenuse. So in this case, cos of x is equal to 3 over 4, or 3/4. Now, cos is a function, and if you're not sure what functions are, that's okay, but to do the opposite of a function is to do its inverse. Just like the opposite of multiply is divide, or the opposite of add is subtract, the opposite of cosine is inverse cosine. Which is this here, cos to the power of -1. That means inverse cos. Okay, so if I do inverse cos of both sides, it undoes the cos here to get just x, and inverse cos of 3/4 gets me inverse cos here of 3/4. I can type that into the calculator. There should be an inverse cos button. There will be a cos button, but if you press shift and cos, then it will give you inverse cos. So inverse cos of 3/4. When you type that in, you get an answer of 41.409, which is 41.4 to 3 significant figures. Now I know these are quite tricky things to do the first time. So have a go at these two examples here, and then I'll go through the working out. Please pause now so you can have a go. So now you've had a chance to have your own turn. Let's go through the working out. So SOHCAHTOA, in this example we have our opposite and our adjacent side. So we're going to use tan. So tan 30 is equal to our opposite divided by our adjacent, so 4 over x. X tan 30, when I multiply both sides by x, is equal to 4. Don't be put off by the fact that we have a divided by x. We can still follow the same method by multiplying by x. The only thing is we then have to have another step in. X multiplied by tan 30 is equal to 4. So we can divide both sides by tan 30. Careful not to divide by 30. That would be a common mistake that some people make. You can't divide by the number that's inside this trigonometric ratio. We have to divide by the whole thing. So if we divide by tan 30, x equals 4 divided by tan 30. We can type that onto the calculator. We get an answer of 6.93 to 3 significant figures. The next question works in a similar way, except this time we're finding the missing angle. We have our opposite and our hypotenuse as given sides. So we can use the sine ratio. So sine x is 3/4, and then we have to do inverse sine of both sides, like I said before, using shift and sine to get the inverse sine, which undoes the sine to leave you with just x on the left hand side. And then we have inverse sine of 3/4 on the right hand side, which when you type in simplifies to 48.6 to 3 significant figures. So here are 6 questions for you to have a go at. Questions 1 through 4 are the standard questions, giving you a bit of practice with finding missing sides and a missing angle. Question 5 is a little trickier, using fractions. And question 6, if you think about it, you should be able to have a good go at it. So here are the answers to those questions. Question 1, we should get x is equal to 5 using the tan ratio. Question 2, we get x is 7.07 using the cosine or cos ratio. And question 3, we have x is equal to 10 using the sine ratio. Question 4, we are again using the cos ratio because we have our adjacent and hypotenuse, so we get x is 44.4 to 3 significant figures. Question 5, we get an angle of 30 degrees. Notice the similarity between this question and question 3. Here, opposite our x is 5/6, and this one is 1 2/3. Now, 1 2/3 is the same as 5/3 or 10/6. Notice that 10/6 is double the 5/6. Here we had 10 and 5. Opposite the 30 was 5, and the longer side is 10. So these two triangles are actually similar triangles. This question, if we use the tan ratio, we get tan x is this side over this side, which will simplify to √3 over 1, or just √3. So the ends would cancel out. You end up with tan x is equal to √3, which if you use your calculator, you should then get an answer of x is equal to 60. Thanks for watching. Hope you found it useful. Speak to you soon.